All of you can give your attendance in the chat box. I repeat, all of you can give your attendance in the chat box. So it is 9:35 a.m. Just give me a minute to present my screen. Can anyone confirm me whether my slides are visible or not?
Yes, sir, visible.
Okay, thank you. So, good morning to all of you. Let me give you a brief recap of what we have did in the last class. If you remember, in the last class, we have started solving problems on stress concentration. We have solved 3 problems on stress concentration, and today we will solve one more problem, and then we will move on to some other topics of this module. So, in continuation with the last class, the next problem in this stress concentration part is the fourth problem, that is this problem. So, let us read the problem. The problem is a rectangular plate 15 thick made up of a brittle material is shown in the figure. Calculate the stresses at each of 3 holes of 3, 5 and 10 diameter. That means what is given to you? In the question, a rectangular plate is given to you. That plate is subjected to a tensile load of 20 kilonewton, as a result of which the tensile stress is induced in the entire cross section of the plate. In this plate, 3 holes are drilled of diameters 3 second hole is of diameter 5 and the third hole is of diameter 10 That means, since there is a change in the cross-sectional area of the plate due to drilling of the hole, so there exists stress concentration. What I need to find out? I need to find out the stresses at each of the 3 holes, and which kind of stress? The maximum stress generated due to change in the abrupt cross section of the material. And in the question it has been given to you that the thickness of the plate is 15 and width of the plate is 25 So if you see in this diagram, 3 holes are being drilled. So we will take one hole at a time. We will find out the value of KT, that is stress concentration factor, from design data book. We will calculate the value of nominal stress for a plate, because if you see the diagram, in this diagram there is a rectangular plate, and in this rectangular plate a hole is drilled. So corresponding nominal stress equation we will write. We will find out the value of nominal stress, then we will multiply the nominal stress value with the stress concentration factor value that we will obtain from design data book. We will get our maximum stresses generated at all these 3 holes. Is the question clear to you?
Yes, sir.
Okay. So let us solve the question one by one. Fine. So what is given? The tensile load acting on the plate is 20 kilonewton. Thickness of the plate is 15 Width of the plate is 25 Assume that diameter of this hole is 3 mm, d1 is 3 mm, diameter of this hole, that is d2, is 5 mm, and diameter of this hole, that is d3, is 10 mm. So we have to find out the maximum stress generated due to drilling of these holes. So the first case is, what we will do, let us take one by one hole at a time. That means in this entire plate, assume that firstly this 3 mm diameter hole is drilled. Then I know that Kt is what? Kt, that is the stress concentration factor, is given by sigma max by sigma nominal. Fine. And sigma nominal for such condition is given by load P, we have did in the last class, that is P divided by resisting cross sectional area. That area, since it is a rectangular cross section, so area will be width into thickness. Width will be this W minus this much diameter hole into thickness of the plate. So width is 25 minus diameter of the hole is 3 into 15, and the value of P is 20 kilonewton. So you can get the value of nominal stress. Yes or no?
Yes,
Sir.
sir.
So if you calculate this value of nominal stress, it comes out to be 60.606 Newton per mm square. Now I have to multiply this nominal stress value with stress concentration factor Kt value. That means for this particular problem, from the design data book, I have to find out the value of Kt. So let us find out. Yes. So the whatever problem is given to me, from that problem, from this particular slide, can I find out the value of Kt? In this particular slide, can I find out the value of Kt?
Yes,
Hello.
sir. First one we can do.
We which diagram we will choose? The left diagram or the right diagram?
Sir, left diagram.
Left diagram, because in the problem it is very much clear that there is a rectangular plate with a hole is drilled. Since three holes are drilled in the given problem, we will take one by one hole at a time and we will get the value of Kt. Fine. In this problem, the diameter D is nothing but A. So the equation is P divided by W minus A into H. H is what? Thickness of the plate. In my problem, thickness of the plate H is T and A is nothing but D. So how I can find out the value of Kt? For that I have to see the x-axis. In x-axis it is A by W ratio. A means dia of the hole divided by width of the plate ratio. So for my question, first of all I have to find out the value of A, I have to find out the value of W, then I have to divide it. I will get one numeric factor that I have to locate it in the x-axis. So let us find out the value of A by W or D by W or D1 by W, because we are considering the first hole diameter, D1 by W from the question. So can you tell me what is D1 and what is W? For the first case, what is D1 and what is W?
P1 is 3
Yes,
mm,
D1
and
is 3 and W is
25 mm.
25. So A by W is nothing but D1 by W. That means 3 by 25. If I solve this expression 3 by 25, then it will come out to be 0.12. That means corresponding to D1 by W or A by W equal to 0.12. What is the value of Kt? So let us find out. Yes. So A by W is 0.12. So this is zero point 0.1 and this is zero point 0.2. So approximately it is 0.12 is nothing but this particular point. This point. Yes or no? Hello.
Yes, sir.
This is 0.12. This particular point is 0.12. So from this particular point, I have to go vertically upward till this graph. Point of intersection of this vertical line and this graph will be a point. From that point, I have to go in negative x direction till the positive y axis. That value will be my kt value. Is it clear?
Yes, sir.
So let us move upward, vertically upward. You will use scale, okay? Then you will get the exact value. So this is your point. This is my point. This is the intersecting point of A by W equal to 0.12 and this particular graph. So from this particular point, I have to go in negative x direction till the positive y axis. So this particular value is what? This particular value is the value of kt, and I can see that kt lies between 2.6. This is 2.8. Definitely this middle line will be 2.7. Between 2.6 and 2.7. So I can take it as 2.68. Yes or no?
Yes,
Approximately.
sir.
I can take it as kt equal to 2.68. So the value of kt comes out to be 2.68. So now what is the value of sigma max? We know that kt is sigma max by sigma nominal. So sigma max will be kt into nominal stress. Nominal stress is 60.606 into kt value is 2.68. So the maximum stress generated nearby area of this 3 mm diameter hole in the rectangular plate is 162.42 Newton per mm square. Is it clear?
Yes, sir.
Any doubt?
No, sir.
Yes, sir.
Okay. Likewise, we can calculate the value of maximum stress for this 5 mm diameter hole as well as for this 10 mm diameter hole also. So the case number 2 is when in the rectangular plate 5 mm diameter hole is drilled. That means this is the condition. In this case, again, nominal stress will be what? Nominal stress will be sigma nominal is equal to P load upon resisting cross sectional area. Resisting cross sectional area will be width into thickness. Width will be 25 minus 5. So 25 minus 5 into thickness, and thickness is common given in the problem that thickness value is I think 15 mm. Yes, 15 mm given in the problem. So the thickness is 15 mm. P is 20 kilonewton. That is 20 into 10 to the power 3. You will solve this particular expression. So you will get the value of nominal stress. And that nominal stress is coming out to be 66.66 Newton per mm square. Is it clear?
Yes, sir.
So since I got the value of nominal stress, now I need maximum stress. For maximum stress, I need the value of Kt. Again, I will use the same design data book figure. So for that, in x-axis, I want what? I want A by W. A is nothing but the diameter of the hole drilled divided by W is the plate. So in this case, A by W will be what? It will be 5 by 25. A by W or D by W, that is D2 by W is what? 5 by 25. If I solve this, particular value, this dyw for 5 diameter hole is coming out to be 0.2. Now corresponding to this AYW or DYW value of 0.2, what is the value of KT? So let us find out. So 0.2, AYW value is 0.2. That means exactly this value. So in order to get the value of KT from this, I have to go vertically upward till where I will, till which point I will go? Till the intersection point of this graph, that means this point. So the value of KT will be what? Okay, for now from this point I have to go in negative x direction. This will be the value of KT, and value of KT is equal to how much? How much is the value of KT? It is 2.5, because it is coming between 2.4 and 2.6, exactly at this point, that is 2.5. So multiply this KT value 2.5 with the nominal stress value for the second hole which has been drilled, and that value is coming out to be, for the second case, that sigma max value is coming out to be 166.65 Newton per mm square. This is sigma nominal, multiply it with KT. The maximum value of stress generated nearby this 5 diameter hole in the plate is 166.65 Newton per mm square. Is it clear? Any doubt so far? Hello.
Yes, sir.
No, sir.
Clear, sir.
Okay, fine. And the last part is, again I have to find out the value of maximum stress for this 10 diameter hole. So for this 10 diameter drilled hole, nominal stress will be again load divided by resisting cross sectional area. Resisting cross sectional area will be width into thickness. Width will be 25 minus 10 into thickness is 15. P is 20 kilonewton, so 20 into 10 to the power 3 Newton. If I solve this particular expression, I will get the value of nominal stress, and that value is coming out to be 88.88 Newton per mm square. In order to find out the value of sigma max, I need KT. Now, if you want to get the value of KT, you need the value of A by W. Here A is 10 and W is 25. So A by W or D by W is 10 by 25, which is 0.4. Corresponding to A by W equal to 0.4, what is the value of KT? So let us find out. So 0.4, this is A by W value or D by W is 0.4. This is that particular value of A by W 0.4. So from this 0.4, I have to go vertically upward in such a way that it should intersect that curved line. This is that curved line. So this particular point, that means from this point, I need to go in negative x direction till positive y axis. That is this particular value. Now this particular value will be the value of KT corresponding to 10 diameter hole, and it is lying between 2.2 to 2.3. So you can take approx value as 2.22 to 2.24. Yes or no? Hello.
Yes, sir.
So let us take that value 2.2 to 2.24. So here we have taken that value of KT as 2.4. Fine. So in order to get the value of maximum stress near the 10 mm diameter hole, multiply this KT with the nominal stress value, that is 88.88. Now if you solve this particular expression KT into sigma naught, the maximum stress induced nearby regions of 10 mm diameter hole drilled in the plate is 213.312 Newton per mm square. Is the problem clear to all of you?
Yes, sir.
Fine. So such type of problems are there in stress concentration part. You can refer book for some more problems. Fine. So this is the variety which you can get in stress concentration. Fine. Only what will change in stress concentration? In stress concentration, this particular thing will change. Sometime this is the condition of the problem, sometimes this is the condition of the problem, sometimes the condition of the problem will be this, sometimes the condition of the problem will be this. So you have to use the correct graph from the design data book, and accordingly you have to get, or you have to design your component. Fine. With this, we have completed the stress concentration part of this module. Any doubt in stress concentration?
No, sir.
Okay. So let us move with the second part of this third module, and the second part is fatigue failure. When how a mechanical body fail due to fatigue, that is design of a mechanical component subjected to fluctuating load. So can you tell me what is a fluctuating load? What is the difference between a static load and a fluctuating load?
Sir, fluctuating load means a load that is gradually applied.
And what do you mean by the term called gradually applied?
Sir, it is increasing with respect to time.
That means I can say that fluctuating load is that type of load which varies in magnitude continuously with respect to time. Is it clear?
Yes, sir.
That is fluctuating load. So in a body, so far whatever analysis we have did, that analysis is for static load. Load was not varying with respect to time. For example, if you check the last problem, whatever we have did in the last problem, on this rectangular plate, a static load of 20 kilonewton is acting, and it is constant throughout the problem with respect to time. But now the condition is different. The condition is the load will not be constant every time with respect to time. The load, magnitude of load will vary with respect to time. Such loads are called fluctuating load, and stresses induced due to this fluctuating load are known as fluctuating stresses. So now can you tell me that in industry, any mechanical component is designed for static load or for fluctuating load?
Sir, for fluctuating load.
Yes, because it is not necessary every time that the load acting on the machine member is static in nature. For example, your vehicle, your four-wheeler. In four-wheeler, many mechanical components are present. When the four-wheeler vehicle is stationary, then the stationary load or the self load of different mechanical component, we will consider that thing into account, and we will design that particular four-wheeler vehicle for static condition. But it is not the case that every time the four-wheeler vehicle will be in static condition. Fine. Four-wheeler vehicle will always be in moving condition. Similarly, in industry, if you want to run an industry, you have to run the machine. And if you want to run the machine, at that time, load cannot be static in nature. In a machine, many components are there. Fine. Those components will also work when you switch on the machine. That means load will vary in magnitude with respect to time. So normally in industry or in real time purposes, we design the component for fluctuating load, because if the component is safe to resist fluctuating load, definitely it will be safe to resist the static load, because in static load the machinery is stationary in nature, failure of the machinery is minimal, but during the working condition failure of the machinery can be maximum. So if a designer design that particular machine component for fluctuating load against fluctuating stresses, definitely that component will be safe to design for static load and static stresses also. Is the term clear to all of you?
Yes.
Okay, so now let us define what are these things. See, we know that so far the external force acting on a machine component were assumed to be static in nature. But in many applications, components are subjected to forces which are not static but vary in magnitude with respect to time. Such load is called fluctuating load, and stresses induced in the component due to these loads are called fluctuating stresses. So, if you have understood the term called what is fluctuating load and what is fluctuating stresses, then can you tell me, if you want to design any particular machine member for fatigue, which type of load you will consider? Will you consider the static load or will you consider the fluctuating load? Fatigue failure of any mechanical component is due to which type of load and which type of stresses? Static load, static stresses, or fluctuating load and fluctuating stresses?
Sir, fluctuating.
Yes.
Fluctuating load.
Yes, so let me give you an example. Let me give you an example. Okay. Can you see this diagram? Can you see the diagram? Hello.
Yes, sir. Yes, sir.
Okay. Okay. Fine. Now, in this diagram, what is this diagram? This is nothing but a wire. Assume that this is a wire. Assume that this is a wire of some diameter. Fine. Now, if you want to analyze the failure analysis of this wire, how this wire can fail? You apply a tensile stress, tensile load on this wire. Can you break this wire into two pieces easily? I am applying a tensile load. I am applying a tensile load at the two end of the wire. Can this wire be broken very easily? Yes or no?
Yes, sir.
How? कहाँ तो टूट रहा है? करो. You take the minimum diameter wire. आपका जो वायर का डायमीटर होगा बहुत पतला होगा. उस केस में आप इसको तोड़ो. आप इसमें टेंसाइल लोड लगाओ दोनों एंड पे. क्या टूटेगा आसानी से?
No, sir.
देखो. हाँ?
नहीं सर.
No, sir.
नहीं टूट सकता. स्टैटिक लोड लग रहा है, नहीं टूट सकता. अब इसको मैं दूसरे तरीके से तोड़ रहा हूं. Same wire of same diameter. What I am doing? From the middle part, say this is a wire of length say 2 meter. This will be the middle part. This will be the middle part. What I am doing, from both the ends, I am applying a fluctuating load which is varying in magnitude with respect to time. This load, sometimes this load is very high like this, sometimes this load is very less in magnitude. Likewise, if you do it clockwise and anti-clockwise, can this wire be broken at this particular point from this particular point? Can this wire be broken from this particular point? Yes or no? Can it be broken? If I do like this, by varying the magnitude of the load, sometimes the load is very high, sometimes the load is very low, sometimes the load is very moderate. Load is not static. Load is not static like this. I am bending. I want to fail. That means moment I am applying. Moment is load into perpendicular distance. Load into distance. Which distance I will take? The middle part distance. So what will happen? Can the wire can the wire be failed easily?
Yes, sir, it can.
Yes,
It will break,
within
sir.
very short period of time, you can break this wire into two pieces. Why? Because you are varying the amplitude of the load. You are varying the magnitude of the load. You are varying the cyclic. This is nothing but a cyclic nature of load. Sometimes this magnitude of load is very high, sometimes the magnitude of load is very low, sometimes the magnitude of load is moderate during the entire process. Fine. So such type of failure is fatigue failure, which generally occurs due to fluctuating load or fluctuating stresses acting in the component. Now is the step clear? What is fluctuating load? What is fluctuating stress? What is fatigue? Any doubt?
No, sir.
Okay, fine. So it is observed that about 80% of failures of mechanical component are due to fatigue failure resulting from fluctuating stresses. For example, shaft, bearing, all the time it is in running condition. So and it is not necessary that on these shafts or on these bearings every time static load is acting. No. So if you want to fail the bearing, if you want to fail the shaft, you have to apply fluctuating load. You have to apply fluctuate, or you have that the bearing and the shaft should resist fluctuating stresses. Due to these fluctuating load, fatigue failure of the shaft and bearing will take place with small initiation of crack. Is it clear? Hello.
Yes, sir, 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 yes, sir.
Okay, so generally these fluctuating stresses are cyclic in nature. Cyclic in nature. So it will follow a cycle, it will follow a curve. So we normally assume a sinusoidal pattern. If I will plot a graph between stress in y-axis and time along x-axis, so as you increase the time, fine. So this is what? This is a cyclic stress. This is a cyclic load in nature. It will follow some cycle, and these cycles are nothing but sinusoidal curve cycles. So there are typically three mathematical models for these kind of cyclic stresses. The first one we call it as fluctuating or alternating stress. Another name of this fluctuating stress is also known as alternating stress, which will alter between a mean value. Alternating stress or fluctuating stress is that type of stress that will alter above and below between a mean value. Second type of stress is repeated stress, and the third type of stress is reversed stress. Now what are these things? Let us understand from a stress versus time curve. This is nothing but a stress versus time curve for any particular machine component which is failing due to fatigue. Fine. Now, if you see this dash 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 line, this is what? This is nothing but your mean stress line, sigma mean, a mean stress line. For fluctuating stress, the stress need to fluctuate above and below this mean stress line. So, from the origin to the maximum peak point will be what? Will be the maximum stress. From this x-axis or from this origin to the minimum peak point of the curve is what? Is minimum stress. And the portion of the stress above or below the mean stress line is known as amplitude stress. That means this is your amplitude stress above the mean stress line. This is your value of amplitude stress below the mean stress line. So we can write the equations of mean and amplitude stress as sigma mean is nothing but, this mean stress is nothing but half times of sigma max plus sigma minimum, and alternating stress, that is this particular value, alternating stress sigma A is what? That is sigma max minus sigma mean divided by 2. Is it clear? Mean stress and alternating stress. Mean stress is half times of sigma max plus sigma mean, and alternating stress is half times of sigma max minus sigma mean. And this is the stress versus time pattern for any particular mechanical component when it is subjected to fluctuating or alternating stress. And why we have taken a sinusoidal curve? Because sinusoidal curve is easy to analyze as compared to cosine curve or tan curve. It can be a tan curve, it can be a cosine curve, but since sinusoidal curve is easy to analyze, so we have taken it as a sinusoidal curve. Is it clear? Hello. Please
Yes, sir.
respond whether it is clear or not. Okay. So this was,
Sir,
yes,
sir, how can we say that it is cyclic in nature, the fluctuating force?
because you, if you want to fail any particular component by fatigue, fine. So you know that you know that the maximum load on this component which you can apply by some testing methods, by some fatigue, you have done the fatigue testing method, fine. In that fatigue testing machine, what you do, you say this is your component, you fix the two jaws of the component and you try to give the, you try to vibrate this component with some amplitude. So this component will rotate clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise between a fixed cycle. That means load can vary from say plus 50 Newton to plus 150 Newton. In between plus 50 Newton to 150 Newton, what you are doing? You are varying the magnitude. Sometimes it is 70 Newton, sometimes it is 140 Newton, sometimes it is 80 Newton, sometimes it is 130 Newton. So if you see, this is what? This is nothing but a cyclic curve, because the loading pattern will vary from that plus 50 Newton to that 150 Newton for a complete cycle, for one complete cycle.
Okay, sir, got it, sir.
Understood? Say,
Yes, sir.
assume that this is, see, say this is your plus 150 Newton per millimeter square stress. This is your 50 Newton per millimeter square stress. In between these two stress region, your curve is repeating. Then only you can fail any particular component by fatigue, or else the component will not fail by fatigue but will fail by some other method or some other process. Yes or no? Hello.
Yes, sir. Right, sir.
Is it clear? Okay.
Yes, sir.
So this was fluctuating or alternating stress. What is repeated stress? Can you tell me from the diagram what is the change? What is the difference between fluctuating stress and repeated stress? In repeated stress, there is no minimum stress. This sigma minimum is zero. This sigma minimum is zero. If sigma minimum is zero, then this particular peak will exactly touch the time axis. That means, see, so this is your mean line. This particular value is maximum stress. Minimum stress is, there is no minimum stress because the peak point is lying on the x-axis. Sigma minimum is zero. And what is the value of your amplitude stress? From the mean line, this is the peak, maximum peak, so this is sigma A. From the mean line, below this mean line, this is the maximum peak, so this is sigma A. So in repeated stress, if you want to fail any particular component by repeated stress, you have to keep sigma minimum is equal to 0. So if sigma minimum is 0, sigma m becomes sigma max by 2, or sigma max becomes 2 times of sigma m. See, this is sigma m, and sigma a is, since sigma minimum is 0, so sigma a is half times of sigma max, or sigma max is 2 times of sigma a. See, sigma max is 2 times of sigma a. This is also sigma a, this is also sigma a. Is it clear? Repeated stress. Any doubt in repeated stress?
No, sir.
The third one and the last one is reversed stress. So can you tell me what is the difference between reversed stress and the remaining two stress? See the diagram and tell me what is the difference between reversed stress and the remaining two stresses. What is zero in reversed stress? Which value is zero in reversed stress? In reversed stress, there is no mean line stress. See, this mean line is not present. If this mean line is not present, that means this mean line will exactly coincide with this timeline. If this is the curve, then the peak which is below the mean line, it will be a negative peak. That means this is your sigma max. This is your sigma mean. But sigma mean is negative in nature. That means compressive stress. If sigma max is tensile stress, sigma minimum has to be compressive stress. If you want to fail any particular component subjected to reverse stress, that means in this condition, the stress condition will be, say, plus 150 Newton per millimeter square to minus 150 Newton per millimeter square, because this value is exactly equal to this value. So sigma mean is 0. See, if sigma mean is 0, that means sigma max will be equal to minus times of sigma mean. If sigma mean is 0, so 0 is equal to half times of sigma max plus sigma mean. So sigma max is equal to minus sigma mean. Similarly, see, sigma max is equal to minus times of sigma mean. And what is the value of amplitude stress? The value of amplitude stress is, this is the maximum peak. We measure amplitude stress from the mean line. Since in reversed stress, mean line coincide with this time axis, so this is my mean line in reversed stress. So this is the maximum peak. So this particular value is sigma a. For positive tensile stress, for negative tensile stress, this will be the value of sigma A. This is the value of sigma A. Is it clear? Any doubt in fluctuating stress, repeated stress, and reversed stress?
No, sir.
Okay, fine. So with this, I end my today's lecture over here itself. From the next class onwards, we will specifically focus on fatigue failure, and we will try to solve some problems related to fatigue failure. So if anyone is left to give his or her attendance, please give the attendance in the chat box. I am here for 1 or 2 minutes more. If you are having any kind of doubts in today's lecture, you can ask, or else you can leave the meeting after giving attendance. Thank you.